Hello, everyone. This is Pat Lynch, and you are listening and viewing the Career Pathways podcast. Joining me today is Dr. Jayson Kennedy, our first two-timer here on the show. So it's a big occasion for us. And also joining us, sitting next to me on my left, stage left, I guess is the right way of saying it, is
producer Jayson. And I don't really know much about anthropology, but I like bones, so I had to come on the show. And
then behind the board, making the magic happen, who is it?
Producer Cheyenne.
Producer Cheyenne. We now have a new name. All right. Well, real good. Well, we're calling this episode Bones and Booze, a walk through history with Dr. Jayson Kennedy. And welcome.
It's great to be back. This is really exciting.
Oh, yes. And this, the great thing is when Jayson and I were talking, and he was kind of explaining. Well, first, you'll see on the table here we have a nice collection of different skulls and pelvic bones, and he was showing how through forensic science you can, there's a whole study of anthropology that you can discover by actually looking at different skulls and how things have changed. And I thought this is perfect, bring you in and talk about that. And so that's one class. We'll give you a chance, and I will shut up and to talk about that class. And then another one you had was this whole it's a biology, anthropology, and I call it Introduction to Alcohol. But what's the course name?
Booze, Past, Present, and Future with Dr. Beezer.
Oh, there you go. That's a winner. Okay, so let's start with forensics. Okay, so how is it that forensic science kind of crosses? How is it forensic science works with anthropology as far as, it's very popular right now. You got all the CSI and all the different investigations. So how is it that an anthropologist gets involved when it comes to the study of forensics?
Well, it largely has to do with the biological recovery of human remains.
Mm-hmm.
Right. So we're using archaeological techniques primarily to excavate human remains. And so this is something we find all throughout the world.
Right.
And what forensic anthropology does is take those methodologies of bioarchaeology and utilize them towards a criminal focus. So we're using those same methods and techniques of recovery to solve crimes.
Right.
And so, when we find skeletal remains out in the woods or something along those lines, and we don't know how long they've been there, we don't know who they belong to, we use forensic recovery methods and archaeological recovery methods to then address that question with the local police.
So how do the local police solve crimes using forensics, using anthropology?
So using anthropology, basically what we're going to do is create what is called a biological profile.
Right.
We're going to take a good look to see what we can tell about that individual, and the biological profile usually consists of age, sex, biological sex, stature, so roughly how tall someone was, and their ancestry, from what we can tell from different skeletal markers.
So for an uninitiated person like me, looking at a skull, a skull's a skull. I could not tell a male versus a female. Now, for an educated scientist like yourself, can you tell the difference?
Yeah, absolutely. We have a female skull here, and there are a couple of markers.
Yep, there you go.
All right, we have a couple markers that we kind of look at, and first being a higher forehead. So typically, biological females have a higher forehead and a more round brain case.
Mm-hmm.
And then we've got a little marker back here at the base of the skull, right here. And it's called the occipital crest or the nuchal crest, and that's where your neck ligaments attach.
Mm-hmm.
And typically for musculature, males have larger musculature, and so they tend to have a more prominent, basically a little notch back here where that nuchal ligament attaches. And so we can see it's more or less a flat-bottomed or rounded occipital portion of the bone with just a small ridge, and so that would classify as female.
Mm-hmm.
And then we see other things in the general facial structure, Our glabellar region is basically the brow ridge. Males have more prominent and pronounced brows. So not quite Neanderthal, but we're looking here at this kind of branch here, and it's a relatively smooth focus here. And then with the eye orbitals, this is thin, right? So again, that brow ridge doesn't carry out through the top of the eye orbital. And we can look at the chin, and typically males have a larger, more prominent square chin. So when we look at any of one of these markers, there can be variation. So we're not looking at saying this chin is female, but rather that it has tendencies that we might call female, and we look at all of those markers together when possible, kind of to create an overall view. Right. So those kinds of markers allow us to kind of identify this skull we would look at if we found it would identify as female, biologically female.
So if you only have like half a skull, it would be kind of tough to...
Well, even if we just had, the mandible here, right? We have that one marker here, but we also have a couple of muscle attachments. And if we kind of look at it next to our male skull, we can see in general it's smaller, doesn't protrude out as far.
Right.
All right. So we can kind of look at those markers. And this is not a particularly robust male either, right? It's kind of, we look at the backside here, that's a relatively small nuchal crest. He's got a relatively small brow ridge, and the same thing with his eye orbitals, and doesn't have a large pronounced chin. So a lot of this would be kind of falling under intermediate features.
Yeah.
But taken together, the skull has more male features, and we know biologically it's cast from a male.
Prehistoric girly man. Okay. But can you time, like on those, is there a way to timestamp like when these these individuals would have lived? Like, was it 50 years, 100 years, who knows how many years?
Definitively on the skulls themselves, no, because you have to take into account the depositional environment. And that takes some research. We would, however, run things like radiocarbon dating.
Right.
We might find associated artifacts. So if they're found with stone tools, then we're probably not modern. Right. So there are markers that we use, but it's not on the skulls themselves and being able to determine age. Now, there are some things that we might be able to look at. Say, for example, if they had fillings.
Right.
Right. So the use of fillings have changed quite a bit in the last. And so if we have more modern fillings, we can place them in a time frame. Whereas if we have traditional gold fillings, we might look at them being more earlier. So there are some things that we can do with that. But typically from the bones themselves, we're not going to get a date unless we radiocarbon it.
One thing I read that was interesting is just the change in humans that in terms of like when the brains were smaller and the face was more wider, that very, very rarely were there crooked teeth. It was always straight teeth, because it was just like with myself, where things are, start to narrow, and I needed braces. So did countless others. Is that?
We call that scientifically maxillary shrinkage.
Okay.
So essentially we chew less now than we had to, because we have softer processed foods.
Right.
And agriculture is really where we start to see this. The shift to agriculture and the use of processed grains and flours, right, really led us down to the point we chew less. And so when you kind of evolutionarily, it's selecting for energy efficiency. And so we don't need it. So if we kind of look right here, I have a Homo heidelbergensis. This is believed to be the last common ancestor between humans and Neanderthals.
Okay.
I lived in Europe and Northern Africa about 1 million to 500,000 years ago.
The brow is huge.
Yeah, the brow ridge is huge, right?
Yeah.
So we can already see that. And the low sloping forehead, right? But if you look just at the size of the jaw and the teeth, right, this is very much what we can kind of start to think about, right? The entire mandible here fits inside of the oral cavity, right? So when we're looking at this, we can see that kind of basic composition. And so this is something we've actually seen. And an evolutionary adaptation to this is that throughout the world, some populations are starting to lose their third molars. So some people are being born without their wisdom teeth.
Yeah.
And so
that's genetically starting to...
Yeah, so we're starting to see almost a third of the population in East Asia now is born without at least one of their wisdom teeth.
Yeah.
And so it's increasing in genetic frequency as we kind of move forward, because there's an evolutionary advantage, especially in impaction.
Yes.
I was going to say, my question would be, so that guy had a lot of teeth, right? And I know, like, we always talk about, like, when we had Kieran O'Keefe, like, George Washington basically had none of his teeth. these people were losing their teeth. Do modern humans lose their teeth more common than like the older?
We absolutely do. And again, it's largely our shift to agriculture.
Right.
Carbohydrates in particular, because they're sugar, they're basically complex chains of sugar. But when you eat a lot of complex carbohydrates and they get stuck in your teeth, right, it's that breakdown of that into sugar that helps to rot the teeth. So the fact that we eat more sugar and more sugary foods and more carbohydrates and they get stuck in our teeth, we see more dental problems today than we did, say, 100,000 years ago as foragers.
Because back then we were just kind of eating like, not raw meat, but like more meats and like, you know, kind of tougher stuff. So our teeth are evolved for
and
that
cooking's 1.7 million years old. We have, Homo erectus is cooking. So this is not, we're not eating raw meat, but in our evolutionary, but we are eating more lean protein. Yeah. We're eating more good starches, right? And we're eating a lot more fruits and vegetables. And those things tend to have benefits for our teeth.
One thing on the skulls that you were showing me that there's the creases and everything on the skulls. What do those creases tell you?
So these are the suture lines that are associated with the fact that when we are born, we have to fit a gigantic head out of a very tiny opening, right? And so if you feel a newborn's head, and you can feel that there are what we call the fontanelles, the blank spaces and very small bony plates, and their head is flexible. Right. And so that doesn't really begin to fuse until about age 2. And then we start to kind of move in. And these suture lines that are on the skull here, hopefully you can see them, right? These are basically the plates in our head that fuse. And this begins to happen around puberty. Right. And so by age 30, we are mostly fused. But what we'll see is over the course of your lifetime, those sutures close, but then they completely dissipate. Right. And so what we can do is use those suture lines as a marker of overall age estimation. So if we kind of look at our suture lines here, you can see up here at the top of the frontal bone and the parietals at the coronal suture, right, running along here, it's very smaller, right? And this is one of the first ones to fuse. It kind of fuses outward, right? And it kind of runs back here. We can see at the parietal and the occipital here is much more open. So taken together, we would probably age this person in their mid-30s. Okay. The older you are, the more those suture lines go away. And so if someone in their 70s or 80s would have very few markers in terms of their skeletal sutures, except down here, some of these in the occipital and to the sphenoid, for example, they don't fully fuse or sometimes don't fuse at all. So we might have some markers that help us to identify that someone's in advanced age. But typically by age 40, we're moving through most of these being fully complete.
Wow. So then that's age 30. This skull would be...
the male here has same kind of thing. She's probably about 35.
Yeah.
The male has some more closed sutures and more along the top of the suture line. He probably falls more along 40 to 45. All right.
Which, if depending on how long ago, that would be kind of the average lifespan. Right?
I mean, for archaeologically, most people would be lucky to make it 40 until about 1800.
Yeah.
That guy, he doesn't really have much, though, on this one right there.
Yeah, this cast, this is a different type of cast.
Oh.
But you can see some of the sutures, but that also helps to kind of identify that these dissipate.
Yeah.
This is a known individual from a forensic case from a gunshot wound. And we know she was in her 50s or 60s.
Okay. Oh. So while we have that, the gunshot, so how, show us the gun. Well, show us the gunshot wound.
Yeah. So we have 3 small entry wounds, right here from a small caliber, probably something along a 32.
Yeah.
Something like that. And so we have 3 small entry wounds. And so the location here, right, from that point of angle, right, we're running out for our exit wounds out through the temple on the other side. And you can see that it's much larger, and that's typically what happens. You get a relatively small entry wound and a large exit wound because the force has dissipated the bullet, and so the bullet coming out has hit bone and has basically smushed out, right? And so you kind of running throughout here, and that force hits the outside of the bone, right? So if you looked inside the skull, you'd have a larger cavity here because of the basic physics, right? The bullet's coming in, and it's creating a force pattern that blows out the inside, whereas here, it hits the inside of the bone and blows out the outside. Right.
Wow. Now, it's something like that, could you tell from that wound if it was self-inflicted or someone or someone that
Yeah, I mean, so
somebody
looking at
externally shot.
so we have another thing on the angle of entry on this
Right.
third shot. That's typically a good sign that it's not self-inflicted.
Right.
3 shots
Yeah.
with a revolver or something like that. That's usually not going to happen, right? But that third
I
shot
walked
is also
into that one.
right. But the third shot is also at an angle. It's at a
Right.
keyhole fracture, which tells us that the angle of entry in each of these is
Right.
changing. And so that third shot is kind of a glancing blow.
Mm-hmm.
It's harder to tell by the exit wound because we basically destroyed the parietal bone here.
Right.
But that angle of entry is at the base of the back of the skull.
Right.
And if you were to think about how you would pull the trigger at that entry, you're likely going to hold the gun down to make it more comfortable.
Right.
And this is kind of coming at an angle across.
Yeah.
And so it'd be kind of holding it like this across the and that's not necessarily where we would think about someone actually shooting themselves.
Yeah, so that was Tony Soprano.
Yeah.
Okay.
And our odds are this person is probably laying on the ground.
Yeah.
When they're shot. So they're shot in the back of the head or in the back of the base of the skull as someone standing over them.
So this is basically what we're going through here is kind of like what a crime analysis would be going through.
And same thing we would be doing and they would be hopefully in whatever context we find, if the body is in the location where it was actually shot, you'd have the slugs to be able to confirm the forensic analysis.
Right.
So you might be able to pull the slugs out of the floor or the wall or wherever we're at.
Yeah. Crime analysis. Explain how is DNA used? You hear it just thrown at, in every TV show and all this, and they got something going on in the lab, and then they have this DNA evidence. And I mean, as an anthropologist, how is DNA used to solve crimes?
Well, so first, this is a better question for Dr. Oliveira.
Yes.
From a perspective here, we're basically working on Locard's principle,
right?
Which is the touchstone of forensic sciences, and that is that when you interact with your environment, you leave traces behind.
Right.
So any interaction, just sitting here in this chair, I am leaving skin cells and hair that are going to allow someone to identify that I'm here. When I walk out, I'm taking carpet fibers on my shoes, right? And so that's Locard's principles of transfer.
Right.
And so DNA, right, can be ascertained through touch DNA. So the oils and secretions on my fingertips, if I touch this table, right, that leaves behind DNA that can be identified. Same thing with my hair or skin cells, right, or bodily fluids, blood or semen. If we're leaving those at the crime scene, right, they can be analyzed. And what we look at is the probability of the match of the DNA.
Right.
And the better our analysis, the better we can match it with someone. And we'll probably get a statistical match of, say, that we have a 1 in 8 billion shot that this is this individual, or 1 in 3 billion.
Right.
Now, that means 1 in 3 billion with 8 billion people on Earth, there might be 2 or 3 people that match this. But were those 2 or 3 people also in Arkansas today, right? So we can kind of work through that elimination. So DNA is, right, we're getting our best possible match with the evidence that we have.
Yeah. Forensics as a career and profession, is it? I'm guessing it's growing, and or is that correct? Or
well, it's certainly growing in popularity, and
but,
because of the interest that the general public has, there are more students who want to take things like forensic anthropology because of the popularity of bones.
Right.
And it's one of the reasons we built this class is because it matches student interest in what they want to learn about anthropology, but also provides training for career pathways. There are career openings in forensic science.
Right.
If you want to be a crime scene investigator, right? If you want to do lab analysis. So you can take the skills that we learn here in biology and chemistry and psychology and anthropology, right? And apply those to criminal perspectives. Yeah. And there are jobs and opportunities for that.
With DNA, is there, as an anthropologist, is that something that just dissipates over time, so you really can't use DNA in your study?
Well, it's true. DNA degrades in environments. Yeah. So, but there are protected portions of the bone, teeth,
right,
the ribs, and the petrous portion of the ear. Those are very dense bone with lots of DNA, and they preserve very well. And so what we can do is we can use those even after a very long period of time when other samples of DNA might not be useful. We can drill into those locations and isolate the DNA there to do identifications. And they've even had great success in this with sequencing, say, for example, the Neanderthal genome.
Mm-hmm.
So we have a pretty good sample of Neanderthal DNA dating back to about 300,000 years. Yeah, I mean, the answer is yes, DNA degrades, but there are portions of the bone that we can still access that are really well protected.
Interesting. Well, let's shift to booze.
Okay.
All right. The whole thing is that kind of walk us through the history of alcohol. It kind of like, I'm sure there has to be somewhere that you could say this is the beginning of alcohol, and then just how it evolved over time to what we see in the present day.
Well, I mean, this is something we just talked about in the booze class, is the drunken monkey hypothesis. And this is a reflection that...
And this isn't slandering any Lyon students.
Right, but this is a reflection that our diets contain dietary ethanol, that fruit on the vine will ferment. Natural yeast is occurring. It can make its way into the fruit bodies, sometimes as soon, even before it's fruit, through the flower, right? And so that banana or that peach has a small amount of dietary ethanol in it. And because fruits are incredibly nutritious and provide us very good energy, we have evolutionarily adapted to eating low amounts of dietary ethanol. We contain enzymes in our body that allow us to process ethanol into acetate for energy. And so what this hypothesis basically states is, well, there is no real starting point for booze because it has been part of our diet for
ever,
as long as they were fruit and as long as we were eating fruit. So evolutionarily among primates, that's at 60 million years.
Okay. But then there is a time, though, where all of a sudden, call it fermentation, started to take place. And when did that begin?
So there's big questions about exactly when, but intentional fermentation likely occurs beginning in the last 10,000 to 15,000 years.
Okay.
So we have a cave in Israel. It's a cemetery. But at this cave, Rockafet Cave, there is basically little limestone depressions.
Right.
And our best guess about what's happening there is they're brewing beer out of wild wheat, wild rye, from those locations because we have calcium oxalate, and it's a fermentation byproduct of grain. So the basins are lined at the bottom with calcium oxalate, and the best guess for what would produce that calcium oxalate is fermentation. Now, it could be storage that just naturally fermented because they left it there and it went bad. Right. But its association with the cemetery is interesting in the fact that this might represent a place where you make beer for the funerary ceremonies.
Yeah.
Now, a little bit moving forward in time at Göbekli Tepe, some of you might know this as the huge site with the pillars that are carved in southeastern Turkey. It's considered by many the world's first temple. Each of those structures, about 20 of them, contains limestone basins either inside them or outside that were able to produce up to 150 liters of beer. And they also contain the same calcium oxalate. Yeah. And so we're making a whole bunch of beer, 150, and it makes sense, 150 liters. And so it makes sense that we might be using that to fuel the ceremonies that are going on inside of these ritually decorated, charged environments.
Did wine evolve at the same time?
So our earliest examples of wine come from the Caucasus, and that's about 3,000 years later.
Okay.
Now we're using grapes. We know that we're using grapes for our earliest beer too. So in fact, our earliest beers are really weird.
Beer?
Well, yeah, you're adding grape and you're adding dates, you're adding honey. Right. Or figs, and all that is designed to increase the sugar content of the wort, which increases the alcohol content. Right. So these are kind of specialty beers. For example, they had analysis of Midas Touch is what was put out by Dogfish Head.
Yeah.
And Patrick McGovern at the University of Pennsylvania did his analysis of what was in the beer.
Right.
And it's all of these really weird things. It's grapes and it's fruits like peaches and things like that are added in there for flavorings. And so, beer isn't necessarily beer in the way we think of it.
It sounds like a hipster bar in Brooklyn. Yeah, that's
we're trying that a lot more with our sours. I think that the Midas Touch in particular, right? It would be more like a
but
like
you can
sour.
use like any fruit. Could you do a concentration of just one fruit? Like, have they seen that, or is it more so like always like this collection of stuff?
So
usually?
I mean, it can. So the Egyptians are primarily using dates,
right?
And so that is kind of what they use to up their sugar content. And so, you can very much specifically use these, but I think that the goal is to add what we can to add sugar to the fermentation process. Now, there's also the daily beer that they're drinking, which is just straight barley porridge.
Yeah.
It's 2 to 3% alcohol, and this is beer that was primarily used because water is not safe to drink.
Right.
And I call it like a barley porridge because you're probably much more like oatmeal, like a really soupy oatmeal where you're getting some nutritional benefits from the grains as well as you're drinking it. And that was served to everybody in ancient Mesopotamia and ancient Egypt by the state as rations.
Yeah. And even infants.
Children were expected to drink this too. And it's a relatively low alcohol concentration.
Versus risking who knows what.
Yeah, it beats cholera.
Yeah. Yeah, I guess so. So then you have beer and wine, and then are there like stages in the the evolution of alcohol? I imagine there's because it's obviously very different here in modern times.
Mm-hmm.
So kind of what were there defined stages that you see?
Well, I think that, for the most part, alcohol remains a relatively low, most drinks remain relatively low in alcohol concentration.
Right.
Until we get to after the Renaissance. Right. So the Romans did have what they called aqua vita. It's a distilled grape drink. So they were able to distill grape.
Like hard liquor?
Yeah,
almost?
it's a hard liquor, a clean grape alcohol. It'd be like basically brandy before it's aged.
Okay.
And so that aqua vita was used for certain ceremonies and as medicines, but it wasn't necessarily drank in the same way that we drink spirits today.
Right.
So the movement towards distillation, and so this in the 1450s or so, we get the introduction of vodka in Russia, and by 1475, the Tsar has basically said all Russian vodka is produced by the state, and I own it all. And so they kind of centralized vodka production in Russia. And it becomes this kind of thing that is used very much as a status symbol and ceremony in Russia. And so distilled spirits kind of change our relationship with alcohol because now we're consuming much more of it much faster.
Wow. When did all the brown alcohols, the whiskeys and everything, when did they begin?
Well, so I'm not going to weigh in too much, but if you want to start a fight, go to Ireland and say it happened in Scotland, or go to Scotland and say it happened in Ireland.
Okay.
So what we have are whiskeys, Celtic nations.
Yes.
Their processes, and that's basically just aging our raw grain spirit. In Scotland, it includes filtering it through peat, right? So roasting the malt in peat. The
sound
earthy.
too appealing.
Well, that's what gives Scotch its earthy flavor, right? So
earthy, yes, yeah, real earthy, yeah. Okay.
But you roast the malt with peat fires, and the smokes help to kind of bring it in, and so you'll kind of get that peat, that earthy tone to Scotch, and so that happens. Let's see, 1600s, roughly. So we have kind of whiskey is emerging and through that distillation process, and then American whiskey comes over with our Scots-Irish ancestry.
I think most of those bottles usually say somewhere in the mid 1800s for most brands that we drink.
Yeah. And it was mostly, a lot of this is all made at home, right? People, it was probably pretty common that just.
Yes and no. I mean, people were making their own brews, certainly, and their own distillates, but at the same time, you had pretty well regulated distilleries, and some of them are still active.
Right.
Speaking of aging, because that's an interesting question that I had, is I always see these videos where they're like, we're going to unearth this thing that's been in the ground for 150 years full of, some alcoholic liquid. What is there certain ages? Could it just age out forever? I'm thinking of wine and stuff like that. Is there a point where it's too aged,
I think that there are certainly wines. Basically, bottle aging is going to increase and the kind of buildup of the materials inside of the wine, right? So you're going to get, there's a certain point where you can store it, but you're not going to want to drink it. So at that point, it becomes more of a status prestige to say, hey, this is Napoleon's bottle of wine, than you would actually ever want to crack it, because it's worth more. Yeah. This is a bottle of wine from 1725 than it is the actual flavor enhancement that it's going to give it.
It would be really disgusting.
Yeah. I think that it would, for the most instances, it would spoil. Now, for the exact age, I couldn't tell you. That's a question we might want to ask Dr. Beezer.
Yeah.
Because we had Beezer on, and he was kind of talking about some of our fermentation stuff.
Well, I tried aging a bottle of Elvis wine that I bought in the late 70s, and it didn't end well. That's all.
But I would imagine that's because there's preservatives and stuff in it now, or different stuff that we put in it that would age it out quicker?
So ideally, you're not adding preservatives to your wine,
Well,
at least good wines. Now, that's not to say that that box of Boda that you've got doesn't have its preservatives to help keep it in there. But
but the real like the prestige reds, they kind of they improve at least for a wine enthusiast if they age to a certain point. Then I'm sure they degrade.
Yeah, there's a point where you're going to want to drink it before it starts to spoil. And it's the same thing with beer, right? Beer is only going to stay good in the bottle for so long. And once you reach that point, you're wasting your time.
Well, so you have you have things like Russia and vodka. Where did gin come from?
So gin was actually started as a medicine. Juniper berries across northern Europe have an antiseptic property, and so the idea of gin is essentially taking that aqua vita of the Romans, that clear grain, neutral spirit, and then adding the flavorings. And quite literally, it was the spoonful of sugar that made the medicine go down. The juniper berries were the flavoring that was enhanced here by monks in the Netherlands in the 1500s, because it provided both the flavor as well as the medicinal properties of the additives. And so they were creating these tonics, the gin itself, as a way to kind of treat specific ailments. And so the different flavorings they added kind of created this. And now all gins contain at least 51% of their flavorings from juniper berries. And then you add other things. So that's the difference between Tanqueray and whatever else is that the flavor compounds that they add. And it can be like orange peel or coriander or something along those lines.
Is that where like tonic and gin comes from?
Well, the tonic is just the carbonated water, right? But
where, as far as in the evolution with alcohol in society, how did religion get involved? Because there's faiths that just view alcohol consumption as just a sin, and then there's others that are more tolerant. Obviously in this country, we had prohibition, and in this county we have kind of a quasi prohibition. So there's a lot of this all is tied into just how religion viewed alcohol.
Right.
So how did that all evolve? Because it sounds like in ancient times it wasn't, it was seen very differently than it is today.
Yeah, the association of alcohol and religion goes back to the origins of religion and alcohol, right? Ancient Mesopotamians, certainly the state, it was a theocratic state,
right?
At least initially. So they controlled alcohol production. They used it to pay laborers, but they also used it to throw festivals. And so beer and wine were included in these large public festivals where you provide everybody alcohol, and you have the hymn of Nicosia, and basically it's drinking beer in a blissful mood.
Right.
And it's basically the equivalent of, let's go to the bar, everybody at the bar get tipsy. Yeah. Right. So the same idea is kind of played out there. You want to drink enough alcohol to where you feel sociable and to where you're agreeable, and you want to hang out with people, and you want to celebrate an honest festival of fertility. Right. So you're doing all these types of things to ply people with alcohol to get them to that place. And people recognize that, right? Because the drinks, right, as we mentioned, they're flavored differently than the daily beer. They might include wine, right, in these festivals. And so we have the same type of idea. And we see the similar things in Egypt, where we have our feast days to all the different gods, and you provide alcohol, and everybody comes out and has a good time at the festival, and you celebrate your religious devotion. I think we see that in early Christianity as well, with Catholic feast days. Right. The church provides wine and beer, and people come out and they have a good feast and to celebrate the day of St. Patrick or something along those lines. Right. And I think the relationship in modern Christianity with alcohol changes because of very specific political processes. And people start, especially with distillation. Right. I don't think people have too much of a problem with alcohol and what we would call today alcohol use disorders. Right. Until we can really up the alcohol content, and it becomes much easier to become inebriated. Right. At that point, it becomes a societal ill when people are dependent on alcohol and are misusing alcohol to achieve a psychological state. And at that point, I think that's when we get a political reaction to that. And so the teetotaler movement that leads towards prohibition in the United States, the relationship between alcohol changes. And so this is one of my favorites. You know, the whole idea of supposedly Marx and Engels say that, you know, drink is the curse of the working class. Right. The idea that the working class drudgery is so bad, your only refuge is drugs and alcohol to escape from it. And then Oscar Wilde turns it on its head, right? And his work is the curse of the drinking class, and because in great fashion, and basically they're recognizing that, you know, that what we would think about in terms of alcohol becomes the focus. Mm-hmm. And when that becomes the case, then people's relationship, you start to get the shift in Victorian England towards moderation, and to remove that kind of temptation. But if there's a Wilde's quip is basically a pointing out that hypocrisy, right? Because the upper class drink more than anybody else because they have the time and money to drink more than anybody else. And so we get that kind of differing relationship. And so people try to control what people drink, and it leads to prohibition. And so at that point, at least in modern American society, the relationship to alcohol changes. Mm-hmm. And it becomes a social ill rather than part of the general solution, as had been seen for most of our history.
We talked about how alcohol is processed differently between men, women, different cultures. Can you kind of walk through how, you know, like Asian culture is, you know, the Asian population processes alcohol different than just say the North American, European cultures. Right?
Yeah, so we can see biological differences, right? And this goes down to human variation in terms of the enzymes that help break down ethanol in the body. And so basically it works on two steps. Ethanol is broken down into acetaldehyde, and then from acetaldehyde into acetate, which is then converted into energy in your body.
Right.
But what we can kind of see is that those enzymes and different genetic alleles in that basically play a role in how effectively that's done. And so for some people, they're really effective at breaking down ethanol into acetaldehyde. But the problem with that acetaldehyde is, right, it's a toxin. Right. Your body doesn't like it. It's going to cause problems over long term. So if you're really effective at converting ethanol into acetaldehyde and you drink a lot, you're going to create a lot of acetaldehydes, which means you also need to be equally as effective with this other enzyme that breaks it into acetate. Mm-hmm. And what we can see in a lot of East Asian populations is that they are fairly effective at converting ethanol into acetaldehyde, but they are fairly ineffective into converting acetaldehyde into acetate, which means that they get the buildup of the toxins. And that's more colloquially called something like the Asian flush. Yeah. It's called general alcoholic flushing. And people who are prone to alcoholic flushing are less prone to alcohol use disorders, because their body is rejecting that acetaldehyde. And so they don't feel good about it. Yeah. Right. And so they do it less. And so there's a less likelihood of building up that dependency. Mm-hmm. Now, there are other genetic mutations that have to do with the reward systems in the pathways, or reward systems in the brain, and essentially ethanol floods dopamine into the system, makes you feel happy and good. That can create different genetic pathways, can create different, more prone towards addiction. Right. In that way. So, you know, it's not just as simple as this alcohol dehydrogenase and acetaldehyde dehydrogenase, but it's what we can see is that there are genetic variations, and some people are less prone to alcohol use disorders. And, you know,
can those mutations kind of like be genetically like, you know how like you have a mutation and then you have an offspring? Could that offspring then have that mutation and keep like that cycle continuing? Or
I mean, so here
like we're passed down traits.
I mean, we're going through, you know, Mendelian inheritance. It's not, you know, not always that simple that it passes from, depending on your partner, right? Because you get your alleles from your parent, both sets of parents. Yeah. So, but yes, it's absolutely possible, and that's likely what's happened towards fixation in East Asian populations. Enough people carry this gene that it keeps passing on, and so that's why we see less likelihood.
We've kind of covered booze past and kind of booze present. What's the future?
I mean, that's a good question. I think the trend in the last 5 years has been towards hard seltzers. Mm-hmm. I think that's kind of where we're going to see most of the market continue to go in terms of the future. But as you and I were talking about in the office, I don't see any future differences in, say, delivery of ethanol. Right. Because, well, we want to drink it and enjoy it. And I don't see a marketing perspective for the efficacy of saying, hey, let's get drunk faster. Right. That's just not a marketing campaign I think anybody's going to go towards. Right. But I think we're going to see changes in tastes.
Mm-hmm.
We've already seen, kind of in my lifetime, Boone and whiskey, and then now it slides off, and now gin is more popular.
Right.
And I think we'll kind of see those shifts. Maybe next time it's rum. And so we'll get those kinds of marketing perspectives that come through in terms of the fads. But I think hard seltzers is really the kind of where a lot of focus has been in the production of alcohol because of the flexibility it provides in flavorings.
Yeah, because you can flavor it with anything.
Yeah, you're flavoring it after the fermentation process, whereas with beer, right, you're traditionally adding your flavorings during the fermentation process.
And now with all the artificial flavors too, you could flavor whatever you want, anything, right? So like you could have flavored, whatever.
Yeah, cotton candy flavored hard seltzer. It was the same thing with cotton candy flavored vodka.
Yeah.
Or anything along those lines.
Hard pass.
Sounds weird.
My head is hurting with just that thought. Well, I think that's that odd but effective way to end this interview. Thank you so much, Jayson.
Well, I appreciate it.
Yes, bones and booze. That's nothing better. So, thank you all for listening to the Career Pathways podcast. This is Pat Lynch signing off. But before I do, say goodbye, team.
It's producer Jayson. Thanks for watching. You can find the Career Pathways podcast on 99.97% of platforms.
And producer Cheyenne signing off.
All right. And we'll have to work on the enthusiasm about where we can be found, Jayson. But that's a whole other podcast. But
nothing
thank
to
you.
smile about in my life.
Yes, but
no cotton candy vodka for me. So.
But truth be told,
it's disgusting. You've saved yourself.
But truth be told, this podcast would never have been able to happen without Jayson and his help. So I kid with him, but I appreciate him every day. So thank you so much for joining us, and please join us again next week. Take care.
This broadcast is sponsored in part by Lyon College and by KILT Studios. Like that? Boom.
Yeah.
You're good. Like that.
How's that?
Good.
It's a little better.
Okay.
Yep, you're good.
I think Jayson, he probably moved that so it covers my face.
No, actually,
It's just on your shoulder.
we were trying to make sure that
I'm vain and insecure, sorry.